Hello friends, our today's topic is adders, half and full adders. Adders are the combinational circuits that performs the addition of the two numbers, but the numbers must be binary numbers. Adders are of two types, half adder and full adder. Now what is an half adder? Half adder is a combinational circuit. Please note that combinational is a key word here. Combinational means you give input and you get output. A very simple circuit which performs the addition of two bits. That means this circuit will have two inputs and it will give two outputs. So please see the circuit diagram here. You will see that X and Y are the inputs while sum and carry are the output. Now we will see the operation of this circuit via this truth table. This truth table consists of input X and Y and output carry and sum. We give different combinations of the input and accordingly we get the output. Let us see one combination 0 0. It means 0 plus 0, the sum is 0 and the carry is also 0. 0 plus 1 is 1 but the carry is 0. 1 plus 0 is 1 but the carry is 0. While 1 plus 1 is 0 with the carry 1. So this is the truth table, and from this truth table we will derive the Boolean equation for sum and carry. The Boolean expression which we get is from the truth table. How this expression is formed? It is very simple. In this sum column, only two rows have sum is equal to 1. For example, in the second row, you have sum 1 if x is 0 and y is 1. So this will be represented as x bar because x is 0 and y because y is 1. You also have sum is equal to 1 when x is 1 and y is 0. So this is represented as x since x is 1 and y bar because it is 0. This is in the form of sum of product. That means your every row is represented as product, and when we shift from one row to other row, you put a plus sign. So you have S is equal to x bar y plus x y bar. Similarly for carry, C is equal to 1 when x and y are 1. So you represented C is equal to x, y. Now if you see these equations, this equation will represent the gate. Like S is equal to x bar y plus xy bar. So this will represent the XOR gate. While C is equal to xy. So this will represent the AND gate. Now from this equation, we will have a circuit diagram. Since you have only two gates, we have represented two gates, XOR gate and AND gate. The input for the XOR gate is XY. So we have input as XY, while the output is sum. So XOR gate has output sum. Similarly, we have input for AND gate as XY. So XY, and the output is carry. So we will represent it by C, that is carry. So this is the half adder circuit. Next we have one bit full adder. Full adder is a combinational circuit that performs the addition of 3 bits, that is 2 bits A and B, and the previous carry, that is C in. So it is adding A, B and C in, and it will again give you two output, sum and C output, that is carry output. So if you see, the full adder has three inputs, A, B, C in, and two output, sum and C out. Now how we implement this? We'll check the implementation with the help of truth table, but please have a look in this circuit diagram. If you see, this is the combination of two half adders. Like we know that one half adder has one XOR gate and one AND gate. One more half adder is here with one XOR gate and one AND gate. And the combination of two, that means the addition of two, which is represented by the OR gate, is the total full adder circuit. Full adder circuit has three inputs, A, B, C input, and two output, that is sum and carry. So this is the truth table. You have three inputs, A, B, C input, and two output, sum and C output, that is carry. Now let us have each input with 0 and 1 combination. So we write down this table. You can easily write down this table if you just see the sequence. The last column has 0, 1, 0, 1, 0, 1, 0, 1. The second column has 00, 11, 00, 11, while the first column has 4041. So this way you can have the different combinations of input. So let us add 0 plus 0 plus 0. So sum 0, carry 0. 0 plus 0 plus 1, sum 1, carry 0. 0 plus 1 is 1 plus 0, 1, sum 1, carry 0. 0 plus 1 is 1, but 1 plus 1 is 0 with the carry 1. So one thing is, the very important, wherever you have two ones in any row, like here if you check out 1, 0, 1. So there are two ones. So whenever you have two ones, you directly put sum is equal to 0, carry output is 1. Here also you have two ones. So sum is 0, carry output is 1. While 1 plus 1 plus 1, this is the last combination where sum is also 1, carry is also 1. Now this, from this truth table, we write the equation for sum and carry output. Sum is again the XOR of all the three inputs. Like in half adder also we had sum equal to XOR of two inputs. While carry we get is C input into XOR X XOR Y plus XY. Now how we got this? Let us check. We have the proof here. Now let us write this sum is equal to, so as we saw in the previous slide, wherever sum is 1, you are simply going to write it in the product form, and at the end you will be adding it. So here you have A bar, B bar, C input. Okay. So here please consider A as X, B as Y. So you have X bar, Y bar, C input. If you check here, X bar, Y bar, C input. Next you have 1 here. So this will be X bar, Y, C in bar. Next you have 1 here. So it will be X, Y, Y bar, C in bar. Next you have 1 here. X, Y, C in. So we have considered AB as XY. You can have the equation in AB form also. Now here what we have done, once we have written the equation, we have taken C in bar common And once you take C in bar common, you have x bar y plus xy bar. From first and last term, we have taken C in common, so you have x bar y bar plus xy. Now, if you just see this equation properly, here we have this as XOR and this as XNOR. Okay, this is A bar B plus AB bar and this is A bar B bar plus AB. So if you just see this properly, so you have C in, this is X XOR Y and this is C in X XOR Y. So at the end, you have this equation as C in XOR X XOR Y. Similarly, for carry output, you have to check the truth table, see where carry output is 1. So here we have x bar, y, c input. Here you have x, y bar, c input. Here you have x, y, c input bar. And here you have x, y, c input. Again, from this equation, you have taken c in common. So c into bracket x bar y plus xy bar. And from these two equations, these two terms, you have taken xy common. So you have C in plus C in bar. So if you just solve this, this will be C in into. Now this is a XOR equation. So x bar y plus xy bar is nothing but x XOR y plus xy. Now what is C in plus C in bar? That means it is A plus A bar. So A plus A bar. So it's the OR gate. If A is 0, A bar will be 1. So what is 0 plus 1? 1. So Cin plus Cin bar is 1. So xy multiplied by 1 is xy. So you get C output as Cin into x XOR y plus xy. So again here sum is equal to XOR of all the three terms, three variables, and C output is C input into x XOR y plus xy. So as I showed you this diagram, this is the combination of two half adders. This is the first half adder which consists of one XOR, one AND. This is second XOR AND. Now if you just check it out, we had sum is equal to A XOR B XOR C input. When check it here, what is the equation for the sum? The equation for the sum is C S is equal to C in XOR X XOR Y. That means it is XORing all the three inputs. So let us check here. So see AB, A XOR B, and again this C in has come here. So XORing means A XOR B XOR C in is the output. So we have A, B, C in XOR, two XOR gates, we get sum. Similarly, C in was what C out equation was C in into X XOR Y plus XY. So let us check out. So this is C output. So C output is here you got A XOR B, you multiplied by C in. So what is the output of this AND gate? It is C in into A XOR B. Here the output of this gate you have connected to AND gate. This is one second input, C input. So C input into A XOR B is this AND gate, and again what you have plus XY. So XY means AB. So this is AB. You got AB here. So this AB and this was seen into X plus Y. So the addition of 2, that is the OR gate, is C output. So sum is what? A XOR B XOR C in. How you have done this? A XOR B you get this gate, and C in you have XORed with A XOR B, you get A XOR B XOR C in. And how you got C output? You got C output as this is A XOR B into C in, okay, and this is A B You OR them